Okay, I'd like to tackle this problem. It's one that comes up in my physics unit of Science 10. And one of the issues is reading the question and pulling out the right information and knowing what that information is. So what I always recommend doing is making a list of what you know and what you don't know. So let's quickly read it. Calculate the average velocity for a balloon car that accelerated uniformly for 3.08 seconds at 1.44 meters per second squared in a northerly direction from a velocity of 2.77 meters per second north. Okay, so if it accelerated from a velocity, then this has to be my initial velocity. So I'm going to start with that one right there, and I'm going to write that as VI. Initial velocity equals 2.77 meters per second. And that will be in the northerly direction. We'll save that for later. We're all going north here, so we'll save that direction for our final answer. The acceleration, A, is, big hint here is this squared value in the denominator. So this value here is going to be your acceleration, and that is also in the north direction. So we know if our first velocity is 2.77 and we've accelerated in the same direction, then eventually we will be going faster. Okay, so the acceleration is 1.44 meters per second squared. The time it took to do all that is 3.08 seconds. And then the final velocity after the acceleration, we don't know. So the question is asking, though, what is the average velocity for the balloon car? So really, in the end, we're looking at having this formula, VI plus VF divided by 2. So that's going to be our V, call it average. So that's our average velocity. So we have this value, and we need this one. So we're going to find that over here using this formula. We've got our standard acceleration formula, A equals VF minus VI all over T. So we need to rearrange this for VF. Okay, so if I do that by multiplying both sides by T, I've cleared out this denominator, which is a good start. AT is equal to VF minus VI. And next, I want to get this VF by itself. So you can consider that some teachers will say, oh, if you take this term over to the other side, it does what? Well, it changes the sign. Algebraically, realistically, what you're doing is you're adding a VI here, and then you're forced to keep everything equal, add a VI over here. And what that does is it'll cancel out these two VIs, leaving you with VF. Okay, so VF is equal to VI plus AT. Okay, so now we just take our information that we have from here, plug it into this formula, and then we'll be able to solve for VF. Okay, so let's do that. We've got, let me just grab that formula. Let's put it a little bit over here so I can work on this side. And we've got VF equals my initial velocity of 2.77 meters per second. I would recommend putting the units in your calculations because it'll be more likely that you get the units in your final answer if you keep them throughout your calculations. So it's just a little note there. Plus my acceleration is 1.44 meters per second squared, and that's going to be times my time, which is 3.08 seconds. Okay, so now looking at the units, we've got these seconds will cancel out with one of these seconds, and then we're left with some meters per second, adding together some meters per second, so that'll keep our units at meters per second. Okay, so next we have VF is equal to, get out my calculator for this one, we have 1.44 times 3.08 is equal to 4.4352. Keep all that there for now. We'll deal with significant figures later on. So we add that then to our initial velocity, which is 2.77, which is a 7.2052. 7.2052 meters per second. So that's our final velocity that's going to go up and into that formula. Okay, so let's just do that. We've got VAV, so our average velocity is our initial velocity plus our final velocity simply divided by 2. And this is just the formula for taking the average of two numbers. And our two numbers in this case happen to be 2.77 meters per second plus our newly calculated one, 7.2052 meters per second. And all of this is going to be simply divided by 2. Okay, so let's get our calculator out again for that. We've got our number still in the calculator. Add to that 2.77, then divide by 2 equals 4.9876. 4.9876 meters per second, and that is our V average. So now the common question is, where do I round this off? So the rules for significant figures, you'll have to check out my other video for that. The rule for significant figures will tell us that in this case, here we've got 3 significant figures, here we've got 3 significant figures, and 3 again for here. So we're forced in our answer to have 3 significant figures. So we'll start on the left side here, and we are moving. Here's 1 digit, 1 figure, 2, 3. So we have to round it off right here. So this 7 will turn that 8 into a 9. So the V average, and you can put this symbol here, it means approximately 4.99 meters per second. Okay? Now, I always ask that you finalize your answer with a statement, so just something simple saying the average velocity was or is 4.99 meters per second. And this tells the teacher, it tells me what you're saying is the answer. So that's always a good thing to be clear, because sometimes I've seen students find the answer and then continue on with further calculations and not really stating what the answer is. So in that way, I have to really take the last line of your calculations as your final answer. And this way here, you've stated it as your final answer, so it's a lot more clear what you're saying is the answer. So a lot of things to be careful of here, including the fact that there was 2 steps. You really want to list the things you know and what you don't know. Figure out how you're going to solve the problem, with which formulas to use, and so on. So hopefully this one is cleared up for now.